Hello everyone. Hello everyone. Today is our second day of Road to Mang series. So let's get started. So today's question is minimum swaps to arrange a binary grid. So let's see the question, then the approach, then the solution, then the code. So a n cross n binary grid is given. That directly means a square matrix is given. In one step you can choose two adjacent rows of the grid and swap them. Okay, so will we the operation given we can perform is to swap adjacent rows like first and second and third. Now a grid is said to be valid if all the cells above the main diagonal are zeros. That means the diagonal above, like this element, and this element, the right side of the diagonal or above, return the minimum number of steps needed to make the grid valid. So how many times we can swap these, we will get the minimum number of grid. If it is not possible, then we have to directly return -1. Like in the second example, it is not possible to create grid valid, so its answer is -1. Now the initial approach is to what is the minimum number of zeros in first row, that is 2, in second row 1, in third row 0. So for a 4 cross 4 matrix it should be 3 2 1 0. For a 5 cross 5 4 3 2 1 0, simply like that. So we have to initially count how many zeros are there, like from the ending, from the right side to left, from here to here, how many zeros are there. If we count those and store it in a list, then directly we can do the operations. So the solution is like we will count the zeros from the ending, right side ending to the initial. We need minimum at least two zeros here. If it is not there, then we will find the number of we will find two zeros from the end in the list. If it is present, then directly we will swap uh, accordingly, like this. Here minimum three zeros should be there. We will start finding in second row. Is there three zeros? No. Again no, again no. So if it is the grid length is over, like the search is over, if there is no single element present in which three zeros are not present, we'll simply return -1. So let's count the number of ending zeros. So first we store n for the length of the grid. uh, we will use it later maybe. So let's iterate and find the ending zeros for j in the reversed. Here I used you for so that I can find directly. No use of range. I don't want to use range. Directly I will access the value. So I will see from the ending how many zeros are there. If j equals 0, simply z plus equals to 1. Z is number of zeros here. Zeros, 0. And if 1 comes, then simply we will break because we are counting the ending zeros only. So last we will append in a list, let's say ending zeros. Ending zeros equals zeros dot append z, number of zeros. We have to create empty list. Okay, so we have found number of zeros, like you can see. Let's print ending zeros. So it will return the for zeroth index. Ending zero spelling is correct. Why it is wrong? Z is not defined. Acha. Oh, sorry, Z. So for zero index, like the first row, second row, for zeroth row, first row, it will store like that. So in this case, in the first case, there are zero zeros in the beginning, like 1 comes to directly we will break cause the ending zeros from the right is 0, so it is 0. In the second, in the first row, there is only 1 0 from the ending. In third row we have 2 zeros from the ending, so we'll store like that. It is correct for all cases, it is correct, of course. 1 1 1. So now we'll count the number of swaps, how many times we will swap. And if we found what our approach is, we will count for 0th row there should be 2 zeros, so we will, there is a pattern here, so it is 3 2 1 2 1, here 2 1. For 5 rows it will be 4 3 2 1. So initially will, if there is no 4 zeros or 3 zeros at the ending according to the size of the grid, we will find from the second row till the last if there is a 0 present or not, and we will simply swap with it directly, not directly, with adjacent pairs, and we will find. So let's see, swaps equals 0. Let's write the code for swaps. So uh, range n, okay, because 3 times we will go for each row, we will go for n times for, okay. So now minimum number of zeros should be equals to n minus 1, cause for 0th index it is, the pattern here is 0 2 1 0, so it is length of the grid minus 1, length of the grid minus 2, length of the grid minus 3. So of course it is n minus I minus 1. So first is n is 3 minus 0 minus 1 2, that is 2. For second row it will be 3 minus 1 minus 1, that is 1, and simply for third it will be 0. So for next index, to check next rows, we'll count j, we'll take j equals I, cause from that we will also check that if that in that row number of zeros, minimum number of zeros is present or not, at least minimum number of zeros. So while ending zeros, ending zeros of I, we'll check if the first, sorry, j, because we are checking from that till the end, j less than minimum zeros or not. If it is minimum, then we will simply go forward, j plus equals to 1, and j must be less than n, cause if the loop ends means we iterated through whole row, all rows, and none, we found none, we found no uh, element in that list in which minimum number of zeros, at least minimum zero number of zeros is present or not. So if j equals n means we iterated all over but we couldn't find, so we'll simply return -1, because there is no element present and having minimum zeros of that, minimum number zeros for that row. So now if it is what if at some case we found at index 2, like in this case we found the 2 zeros here, so we will this while loop will be break, of course. So now we'll check uh while, if we will swap 2 times, so swaps will be equal to j minus I, of course j minus I, cause j is the second row and I is the first row, because for the 0th row, sorry, so 2 minus 0, that is 2, minimum 2 swaps, that is first and second, then second and third, then first and second, we will swap with it. Like this example, best example, it is given already. So now we got the swaps, j swaps plus equals to, because how many times we don't know, we will swap it with. Now we will swap while j is greater than I. So when j is in between in between I and n, including I, so we will swap ending zeros. We don't need to access the grid itself. We will the list we made of ending zeros, we will simply check that. uh we will swap the ending zeros values and check, and we will swap those j comma j minus 1, of course that would be a previous value. We will swap these. After swapping these, 1, of course we will simply come backwards. So let me finish the code. So at last we will simply return number of swaps. Okay, so this part of the code is a bit confusing. Let me explain again. So initially we stored all the zeros, ending zeros for each row, and now here we calculate the uh, number of swaps. So how we calculate? For each row, we know the minimum number of zeros we require. Like in this case, let's see the first example. We need 2 zeros. So minimum number of zeros we get from this. And for why we took j as another value. So j will check. J will iterate from. J will check from this to this. Is there any uh, the ending number of zeros, is there more than it or not? If it is more than it, then simply the while loop will break and we'll get it, the number of swaps. How we'll get? We'll get that that index minus the index in which we are present. So when, let's see this example, 0 0 1, the ending number of zeros is 0. So it went through, minimum number of zeros is 2, j is equal to 0, while j is less than l, the value of j now is 0, it is true, and ending of 0, what is it? It is 0. In the first case it is 0, see. So we need two two zeros. So is it 0 less than 2? Yes, then j plus equals to 1. Then again, now j value is 1. Ending of zeros of 1 is 1. 1 is less than 2? Yes. Again, 2 is less than 2? Yes. So it went till the last. Okay. So now we will swap less than minimum zeros. Okay. So now at last the case 2 is less than 2. False. The condition is false. So while loop will break here. By mistakenly I have said yes. The while loop will break at 0 1 2, at 2 index. 2 is less than 2, which is false. So this while loop break. Is j equals n? No, j value is 2, but n value is 3. So it not return -1. Swaps is j minus I, 2 minus 0, because now I value is 0. I value is still 0. So number of swaps is 2. That is, which is correct, of course. From here to here, it will take 2 swap at least. So now we calculated the swaps. Now what we'll do is swap these in real time. So what we'll do is we will uh, we will swap not the list element, we will swap the ending zeros list. So now we will swap 0 and 1. We'll first swap. Okay, so we'll first swap the index of 2 and 1. We'll swap these two first. From the last, we've same it is. We'll swap row 3 and row 2, and then the row 3 will go to row 2 will go to row 1. Then now j value is 1 and I value is 0. Now we'll swap row 1 with row 0. So row 1 became 001 and row 2 became 00. Okay, let me see. First is second row became so row is 0 1 and 2. So first it went second last row became first row, so it is 1 001 100, then 110, then again 100 001 and 110. Okay, so now we took two swaps. We will uh, swap these values. So the swapping took like this. Here, so the list became like this: 0 1 and 2. Then it became 0 2 and 1. Then it became 2 0 and 1, like this. So first now the zeroth row is correct, all correct, so it is already set. So now I value will go 1. So now we'll do for this, and same the repeat, it will repeat. So this is the dry run part, I would say. So let's check if it is correct or not. Yes, it is correct. Let me submit again. I have submitted already. Of course it is correct. 0 millisecond. Wow, 100% bit. Impossible. So for today, this much. From next time, maybe we'll do NSTQOTD as well. We are with a streak of 186. Tomorrow we'll go 187 maybe. So this is the question. We try to optimize it further every time we see a question. So bye bye.